Welcome to Macmo Academy. Dear students, in this video we will understand inverse of a function, and we will also see in this video that how to find the inverse of a function and how to write its notation and how to find the domain and range of inverse of a function. So first of all, we need to understand that what is mean by inverse of a function. So by the definition, an inverse of a function is a process which reverses the input output process of original function. What does it mean? It means that, for example, if we have a function, you all know that how to find the value of a function we have already done in our previous video. Whatever the function is given to us and we are doing f of 2 of it, means we are putting the input 2, and let's say we are getting the output 7. So what will happen in the reverse of it or inverse of it, that when we will put 7, it will give us 2. So it reverses the input output situation. So in the original function, if we were putting the input 2, we were getting the output 7. But in its inverse, when we will putting the value 7, we will get the answer of the function 2. So I have written one thing over here, f power minus 1. This is the notation of inverse of a function. This is the notation or representation or inverse of a function. Now, you need to clear one misconcept over here, that inverse of a function does not mean 1 upon f. It is something else. Usually when we talk about the inverse, we sometimes say the reciprocal. Sometimes, for example, if we will say like this, so sometimes you think that inverse means it's reciprocal. So this is not the case in the inverse of a function. So don't mix it with the reciprocal. Reciprocal is something else. Now we will understand that how to find the inverse of a function. So let's take an example. And the process is very simple. Let's take an example over here. Let's say we have a function. Question is find inverse of f of x is equals to 2x plus 5. So this is the original function, 2x plus 5. So whenever you want to find the inverse of any function, I'm not talking about only this one, but if you want to find the inverse of any function, we mention it as f of like this. This is the notation of a inverse of a function. So what you need to do, you need to take your original function equals to y like this. This is one of the way. There are some other ways of finding the inverse as well. This way is applicable in so many range of the questions, so we should use it. It is very easy as well. So what you need to do, I am repeating, whenever you want to find the inverse of the original function, you need to write your original function and you will take it equals to a variable. Right now we are taking it as y, and generally we take it as y. Now what you need to do, you need to find the value of x from here. What you need to do, so to find the value of x from here, you need to move the other things from here to the other side towards y. So you will get 5 will go there, so it will become y minus 5 is equals to 2x, and then 2 is multiplying over here, it will go there and divide by y minus 5. What have you done? You have taken your original function equals to y, and then you have isolated x. Now what you need to do, you just need to replace x with y. You need to replace x with y. So you will get x minus 5 upon 2. This particular expression is actually called the inverse of the original function. This is the inverse of the original function, and you can verify it as well. So as it is written that the inverse of a function reverses the input-output process. So what is the process in the original function? In the original function, the process is that your variable is multiplying with 2 and then adding with 5. Multiplying with 2 and then adding with 5. So what is the reverse of multiplying? Division. So you can see now it is dividing by 2. And what is the reverse of the addition? Subtraction. So you can see over here now 5 is subtracting from here. So you can see it reverses. So this is how we find the inverse of a function. Let's take one more example. Alright students, now we have a question in which there is a function given, f of x is equals to 3x plus 4, and you need to find the inverse of it. So let's see part 1 first. So in part 1 again we will take our original function equals to y, and we will get the inverse of a function by isolating the x, y minus 4 upon 3 is equals to x. Or when we will exchange x with y, originally we will get f of inverse x is equals to x minus 4 upon 3. Now in the second part it is written that you need to find or evaluate. We have already done this type of question in which we need to put the input and we will get the output. So it is written over here that find f inverse of 10. Okay, f inverse of 10. So what does it mean? That in place of x you will put 10 in the inverse function equation in this one. So now put the value for part 2. So in part 2 it is written f inverse function, you need to put the value 10 in place of x. So where is x? X is over here. So 10 minus 4 upon 3. So you will get 10 minus 4, 6. 6 upon 3, 2. So the answer of this is 2. So this is how we can evaluate our inverse function as well, like we have done our original function in our previous videos. So now let's see that we have done that how to find the inverse of a function, how to notate it, means how to write it. And now we will find that what is the connection between domain and range of a original function and inverse of a function. Let's see. Now for domain and range of inverse of a function, the relation is very simple. Look over here. Domain of f means original function is equals to range of f inverse, and range of f means original function is equals to domain of f inverse. So the relation is very simple. That for example, if you have a function f and its domain is, you know that you can write like this as well, 1 comma 2, 2 comma 3, 3 comma 5. So what is the domain of it? What is the range of it? So its domain is 1, 2, 3, and its range is 2, 3, 5. Now if I use this particular relation of domain and range, we can say one thing, that the domain of the original function will become the range of the inverse of the inverse function. We can check it. So for inverse of a function, as we have already discussed, that the input will reverse with output. So here the domain or the inputs will become outputs and outputs will become inputs. Let's write it. It will become 2 comma 1, it will become 3 comma 2, and it will become 5 comma 3. Now by using this concept, if I will write the domain and range of this function, the inverse of it, we will get the domain 2, 3, 5, and we will get the range 1, 2, 3. So this is very important thing that you need to remember, that domain of original function will be equal to range of the inverse of it, and range of original function will be equal to domain of the inverse function. So for this you don't need to do any extra question right now. You can do it by yourself as well. Whenever you are trying to find the domain and range of the inverse of a function, actually you need to find the domain and range of the original function, and then you will use this relation to find the domain and range of inverse of a function. Here one thing is very important that you need to understand. For example, if you have a condition like this, as we have already done types of function. So if you have an original function like this, 1 comma 2, 2 comma 2, 3 comma 5, let's say. So the domain of this particular function is 1, 2, 3. But what will be its range? Its range will be 2 comma 5. As the range is repeating over here, and it is possible for a function that the output will be repeated. Input should not be repeated, the domain should not be repeated. Then it will not be a function. But now if I want to write the inverse of it, that there will be one issue. You can write like this: 2 comma 1, 2 comma 2, 5 comma 3. Now there is one issue, that if you will see over here that the domain is repeating, so it means that it is not a function. So this particular relation is only applicable on 1, 1. If you have remember the types of function, we have done 1, 1 function in which every input has unique output. The output is not repeating. The output is not repeating. So this particular relation is only applicable on 1, 1 function. And if you want to find the domain and range of inverse of a function of other types of functions, then you need to solve the equation. For example, if you have an equation f of x is equals to 2x minus 1, then you need to put different values of x, or maybe the sets of the, maybe the range of values of x will be given, that x is equals to 1, 2, 3. Then you will use this particular values as input to find the output. Let's say we are trying to find f of 1, means 2 ones are 2, minus 1 is equals to 1. So if the domain is 1, 2, 3, then range will be plus 1 is 1. Now for f of 2, we will get 2 to the 4, minus 1, 3. Then for 3, we will get 2, 3 the 6, 6 minus 1, 5. So this will be the range of it. Now you can reverse it to find the domain and range of the inverse of it, of the inverse function. So this is also one of the way to find the domain and range of inverse of a function. So this is it from this video. In this video we understood that how to write the inverse of a function, and remember that you don't mix it with the reciprocal. Reciprocal is not same as inverse of a function. And then we have done that how to find the inverse of a function, and then we understood that what is mean by domain and range of inverse of a function. So you need to remember this particular relation for domain and range of inverse of a function. Thank you for watching the video, and if you like the video, don't forget to subscribe our channel.